All right, hi, welcome. And today we're going to continue the learning the Zig journey. So today this stream is part 4 of the series. So again, what we are going to do in this stream is to go through the exercise in the Zigling repository. So in the last one, we have finished all the way up to quiz 5, the exercise 44. And so today we will going to continue on 45 and then see how far we go. Try to aim the stream for about half an hour or so, and we'll see how we go there. So the reason for me to doing this exercise, number one, is learning a little bit about the Zig language. Again, the Zig language is the language that's written, that's used to write the new Bun JavaScript runtime. Right, so for myself, I am interested in the language because I want to learn how it designs the language, as I'm trying to work on the just-func language myself. So one of the interesting thing about the Zig is about is control flow analysis, is type, is able to use type as kind of as value. And also it doesn't have macro, so that is a difference between Zig and Rust. So those are some of the things I want to learn from it. So without further ado, let's get started. All right, so let's continue. So exercise 45. So it's about optionals. So sometimes you know that a variable might hold a value or it might not, right? It's the idea between options, or in Haskell is called the maybe type. It is a very neat way to handle the what they call the null reference. So Zig has a neat way to express this idea called optionals. The optional type is just put a question mark in front, and then so it can be null. It's nullable in TypeScript term, right? So this is setting it to null. If this null, then it's do something, so that's fine. Before we can use the optional value as a non-null type, we need to guarantee that it is a null. One way to do this is to threaten it with the or else statement. Okay, so this is kind of like the unwrap or in Rust. So again, Rust also have the optional type. So, but just the syntax is a little bit different. So over here, let's go into the exercise. Please threaten the value. That's an interesting way to describe it. So that answer is either the integer value from default or number 42. So it would say oh, okay, so just or else 42. Right, and then this will return null because it is it allows it because it is optional. So a blast from the past. Optionals are a lot like error union types, which can either hold a value or an error, which is true, right? Which is I mentioned that when we look at the error in the previous stream. Likewise, the or else statement is like the catch statement used to unwrap a value or supply a default value. So what I like about it is it have a keyword for it, but at the same time it's also a disadvantage because this is very specific to optional type, right? So say compare in Rust, optional type is just one of the types that is out there and is using some standard patterns. It's a function, so it's kind of like you have a let x, assuming that is the value, the optional type value, and then let y equals to x unwrap or I can't type unwrap or else, right? And then put in a 42 over here like this. So it is kind of using the OO style, or in Rust term is using the traits to do this. Of course, I haven't write Rust a little bit. The syntax might not be exactly this, but you know that's the main idea. So in Sig, this is a part of the language, right? So, and the same thing for catch, right? So this get me thinking, do we need both? Right? Is there a way to, does it make sense to just have a standard way or a common way to handle it? Although I understand, you know, error handling is a very common way, and well, I should say a very common things to do. At the same time, the optional type, right? It is kind of not saying newer. It is also very common in functional language. But in non-functional language, in OO, or say you come from Java or C# or in TypeScript and so on, you know, you can add this optional type, but it is not part of the language, right? So this is a choice that the language make to make this the optional type as part of the language. Right, so when you do that, yeah, I would say it's okay to add a syntax specifically for it. But at the same time, if I'm designing the just-func, I'm thinking, well, is there a more generic way to handle it, right? Because in if you really think about just functional programming, this is a union, right? Or if in term of just-func, I'm thinking about is just a tuple, is a glorified tuple that allows you to contain two different types of data, right? One is the original data, right? In this case, the U8. And then the other one is, in this case, is null, right? Because it's optional. And for error, for this, the other type is error. So you can think of it as really just a union of either U32 or U8 over here. And then the other one is either null or error, right? If you think about it that way, maybe it makes sense to just have one form or one keywords to handle that. Right, but anyway, that's one observation I have. So let's run the build. So yeah, that passed. So let's move on to exercise 46, optional 2. Is it? I want to make sure, give me a second. I want to make sure. Okay. Yeah. So now that we have optional types, we can apply them to structs. The last time we checked in with our elephants, we had to link all 3 of them together in a circle. So that the last tail, or the last example, the A reference B, B reference C, C reference A. Right. This is because we had no concept of a tail that didn't point to another elephant. Yes. Let's go back to that example, see if we can find it. Oh, it's in the pointer. I think it's over here. Where is it? Oh, here. Right here. So this is not an optional type, it's just a pointer, so we have to initialize it, I guess. So say actually we can give that a try. So if we comment these lines out, we forgot exit with error code 3. Expected 0. We forgot elephant B. I don't know. That's one. Yeah, because the thing is, I don't see where this elephant B string, this error is getting printed out. That's weird. Hint, oh no, we forgot elephant B. Let's see, it doesn't have a name. And I comment C and A out, right? Why it talk anything about elephant B? Actually, I don't know where that comes from. Yeah, this is a little bit mystery to me. I was expecting either it's fail with a compile time error because it is saying, oh, we have this type, but it was not defined, right? It was not initialized in the code, so it fails. Or it allowed it to go through and then failed at runtime to say is crash or something. Right, so yeah, but it's neither. It say forgot elephant B. Where is this got print out? I can't tell. Yeah, that's interesting. Well, don't know about why is that. One second. 44. Yeah. This is correct. This is for 44 failing. Don't know why. Okay. Back to here. We also introduced the handy dot question mark shortcut. It's the same as or else. Unreachable. Okay. So if you can find any variant shortcut below, let's see. The tail needs something, so we want to mark that as a optional. we should stop once we encounter that does not point, so this will break. Yes, is. And then what happens? So if we reach, because we break out over here, so this we guaranteed to be actually contain the container value. So this basically does nothing except just silencing the compiler. So let's see. Yeah, that passed. However, well, I feel like this is a little bit unnecessary, and it's probably is not a good demonstration of how this can be used in real life. Because if you're really doing this, right, this looks very extra, right? Because here you already do the check to make sure that it is not it is now you break away. So although at the same time, the language, well, that's how it works though. The if statement is checked, if it is no, then it goes away. So if on the other hand, another way to do this is e.tell, and then get that, well, or else say no, for example, right? Then we will still say if e.tell equals to no. Right, and then break, right? It doesn't benefit from it at all, right? Yeah, but it is what it is for now. And let's just take a look. What if we do not set it to optional? So 9 here is a expect type, but it will be accept no. So how about set it to undefined? Right, that is just saying it haven't been initialized yet. And of course, well, I would expect this to fail completely. That's not how the language works. I don't expect this to work. Yeah, so it failed the same way, although the hint is. How does it work? My guess is it have something in the code, some other code, but that's nothing else. Maybe over here? No, this is just some patch that doesn't really make too much sense to me. Oh, maybe over here, hints. Okay, 46. Yeah, I see. There you go. So elephant, I see. So it do the check. If it is the output is not what it expected, then it print out that hint. So that's where it comes from. So the one that we saw over here on the quiz 544, I say, oh, we forgot elephant B. So that's where they come from. I see. So these are the exercises, and then it check the version. It try to build. Yeah, that's just some code over here. I don't know. All right, never mind. So this means that it passed the compile time and only failed at runtime. Right. So I actually didn't expect that. Although at the same time, I kind of expect that a little bit because this is a pointer, right? So this is really the undefined, is really the real null reference pointer. Because when we say this is null, it seems like null is also a value in Sig, just like in JavaScript. So that's why the compilation failed with here, but with undefined it passed. Right. Well, let's not mess around with it and get it back to this to make sure that it passes. Right. Anyway, so let's move on to exercise 47. So help, evil alien creature have hidden eggs all over the earth and they are starting to hatch. Before you jump into battle, you will need to know 4 things. You can attach function to struct. Okay, just define a method basically. A function that has a number of struct called method, yes. The neat feature of method is the special name, right? This or the closure if you think about functional programming in JavaScript. So it get the self, it's specified it is bar. Well, because we named that as bar over here. Actually, you can name the first param anything, but please follow convention and use self. I see, because over here the self, it is just the name of a variable. So that points out one interesting thing in TypeScript, right? So in TypeScript right now we have the special syntax if this equals to whatever and then something else, right? Argument, say for example a number and then do something. So this is telling TypeScript that this function is meant to be used as a method inside a object of type this, right? Say for example it have a value a number, and then so over here you can say this dot a equals to 1 2 3, right? So that's how TypeScript does it, and because it adds on top of it adds the type system on top of JavaScript, so it has to do this kind of a little bit hack way to describe how this should be in the context of the function, right? But over here it is just a variable, right? The name of a variable is called self. It's just by convention it's called self. Now when you call the method over an instance of that struct with the dot syntax, the syntax will be automatically passed at the self. Well, yeah, nothing special. So we hate this. Let's see. Alien, it have a health. It return a new alien. Okay. Your trusted weapon zip those alien. So it point to for this second. This is using the struct bar directly. It's not a pointer. It's copied by value. How does it work? This is Interesting. I'm going to try that out. So let's see. So we keep checking to see if we kill all aliens yet. Okay. Oh, I see, I got it. So over here, this is, it's not that saying this method is bad. This is really just a static method, quote unquote, right? Or the constructor function to create a alien, which is true, which is how it works. So that's fine. So this is creating 6 aliens, and it looked through the alien to see how many of them is still alive. Okay. So this would be simple hit rate. Zap the alien. I can't spell. So yeah, so this pass a alien pointer over there, and so that it can modify. So I think that would be it. Yeah, there you go. Right, so one interesting thing is over here, this is not the same as in the example over here. Right, so I wonder what happens if I do it like this. It also passes. Yeah, so in Rust, this is probably will be a pointer because that's what it is. And using a pointer makes sense over here. Right, it's just that actually this one doesn't make sense because this, if you go back to C code, this is passing a passing it as a value. You basically you're saying you're copying it or something like that. So I would say we normally shouldn't like this, but at the same time, you can see that when it does this, this still works, right? So this is a U8. Let's see what if we try to modify it. Does it have minus? No. Minus equals to 1. Cannot assign to constant. To constant? Yep, so that works, right? So this, it does seems like it's copied, but it's different, right? It's different than passing the value. Of course, passing by reference, right? Passing the pointer in, right? So that is what we expected, right? What we should be doing normally. The interesting thing is it allowed this, right? It also allowed this, and this works. So what if well, the thing is I remove it, it also working, right? This also go on to the next exercise. Well, if I change this damage to 6, yeah, so that is not right. So it does seems like this is getting a copy of the instance that we get over here, but when we get a copy, somehow it is a const. It's a constant. So it's an interesting observation. But anyway, in the context of the language, where when you're passing the self in, it should be a pointer. So that's that. Again, now the test pass, or the exercise pass. So let's move on to the next exercise. Exercise 48. Now that we have seen how methods work, let's see if we can help our elephants out a bit more with some elephant methods. So get tail. So this is returning a elephant pointer, and then it use this optional say an else or else unreachable. So that means if we call it when it is really null, it will fail because it reached that unreachable. Okay. Yeah, I don't know how well this idea will go. And I'm thinking, what I'm thinking about is how does it compare to Rust, right? If I do this in Rust, will it be different? Because this does allow you to do crash, quote unquote, in the runtime. But of course, in Rust you can also panic, right? That's not a problem. Not saying that it won't, right? I'm just interested in the structure of the language. You know, how does it work, right? So. So let's see, has tail, so that's fine, visited true, so yeah, so that's basically just putting the function, the values that we used to do inside the for loop, inside into the elephant. Right, so let's see. If it has tail, then it get tail. So that's that. There you go. So the question is, you would like to know what happens if you don't call it. Right? It will just panic. Yeah, I think this error code 3 means it panics, right? It reached the unreachable. So that's what that is. Okay, so quiz 6. So trunk and tail, oh, isn't that the same thing? Okay, now we have tail all figured out, can re-implement trunks. Okay. So get the tail method, and then the trunk method. What do we want to do with it though? Public func. Let's see down here. Has func and get func. Okay. Extra func. We need to say self pointer elephant. Oh, I'm not writing TypeScript. Right, self dot not equal to null. Right, and then pop func get trunk self $elephant, and then it is elephant. So self dot, basically the same thing. Right, so it's just pointing to the periods, so basically making it a double linked list. So yeah, that works as expected. All right. Yeah, okay, so we passed quiz 6 and we are about time also, so let's wrap up. Well, let's see. So what have we done in this stream? Well, we go over the optionals. So again, optional is a type that allow you to store two values, either the value that you specify or null, right? And in Sig, it make it all the way into the language syntax so that you have this or else. Unlike in Rust it just is a function. It's using a trait, a enum actually, to implement the this data structure, right? Because at the end it's really just a data structure. Think about it's a union or it's a tuple. I really should say it is a union because it just have one storage space to save either the value that you want or null, right? When I say a tuple, it's really a tuple of two elements, is one or the other. So when I say tuple, is practically not correct. But for myself, I'm thinking about in just-func how am I going to implement it. So that's why in my mind I keep thinking and saying tuple. So it is really a union type, just like the error case, right? You have a return value or a error. So I said that there is a concern in terms of the language design to having two syntax to do essentially the same thing. Of course, the thing is because error handling and optionals using fancy word to describe is semantically two different things, and they are probably critical enough to warrant them to have different names and different keywords to handle them, right? So I'm not saying it is a bad decision, it's just a choice, right? And as for myself, I'm thinking about that. Should I have two different syntax or two different functions to handle the same mechanism, right? Basically extract a value from a union type. One is the primary value, the other one is a subordinate value, right? Either null or error in this case. So that's what options is. And then you go for methods, nothing really special, right? In the struct you can define a method, you're using self, and it should be a pointer as expected. So over here I feel like it probably should add a pointer over there to avoid confusion. As you can see, when we try to play around with it, the value is what the result is a little bit surprising. So probably I will create another PR about that. Right. So yeah, other than that, it is an interesting way to demonstrate a double linked list using elements. So yeah, that's it. So, and that's it for today's stream, and hope you enjoyed it and hope you learned something. And as always, if you have any question, feel free to ask me, and you're encouraged to go to the Ziglings GitHub repo to give them a star, and also fork it so that you can try to play along with the exercise by yourself, or either with me when we're doing the streaming or when you're watching the stream. So anyway, thank you for watching, and we will see you next time. Bye.